Hi class, welcome. Today in class we're on the 5th in our red packet. We're going to do chemical weathering reading along with the flow chart. Your homework for tonight is going to be to take a picture of weathering or find one and print it out. Alternatively, if you can't take one or print one out, you can draw a picture of weathering. Your picture of weathering may be mechanical weathering or chemical weathering, which we'll learn about today. In our red packet, we're going to turn to page 6. This week we're practicing writing in the margins. Yesterday we did visualize, so we are visualizing our text and drawing pictures in the margins. Today we are going to use the strategy of summarize. So in all of your margins or blank spaces on your page, you will be summarizing the text. For summarize, you briefly summarize paragraphs or sections of the text. Summarizing is a good way to keep track of essential information while gaining control of lengthier passages. Summaries will state what the paragraph is about, describe what the author is doing, and account for key terms or ideas. So all we'll be doing today is writing a brief summary next to our passages in our text. Last class we talked about mechanical weathering. Today we are going to talk about its friend, chemical weathering. We are on page 11. Just like last class, in the upper right hand corner of the packet is the instructions for this. So in this section of the textbook from CK12 Online Resources, you will be reading about chemical weathering. What is our subject? Chemical weathering. As you read, please use the annotation method of summarize to identify key concepts in the margin. After you read, complete the flowchart on chemical weathering. So we're going to read through all of this. We're going to summarize each paragraph. And when we're finished, we should be able to complete this flowchart. Please take out your highlighter or pencil to underline, and we'll go through these first maybe 2 or 3 paragraphs together. And then with the sub, you can continue the rest. So our objectives for today are to define chemical weathering and describe the various processes of chemical weathering. How do rocks turn red? In the desert Southwest, red rocks are common. Tourists flock to Sedona, Arizona to see the beautiful red rocks, which are set off very nicely by the snow in this photo. What makes rocks red? The same process that makes rust red. First thing we need to do in our paragraphs are identify any words that we don't know and define them. Please pause the video and discuss any words that you are unfamiliar with and write a definition next to the word. Great. Next paragraph, chemical weathering. Chemical weathering is the other important type of weathering. Chemical weathering may change the size of pieces of rock materials, but definitely changes the composition. So one type of mineral changes into a different mineral. Chemical weathering works through chemical reactions that cause changes in minerals. The first thing that we need to do when annotating is highlight the important parts or underline them. What do you guys think is important in here? Please pause the video and discuss. If I were to highlight in this passage, I would put changes the composition, because our chemical weathering is definitely changing the composition, and it works through chemical reactions. The next part of summarizing through annotation, or annotation through summary, is to write about a 1-sentence summary. It shouldn't be much longer than a 1-sentence summary in the margins. So if we wanted to summarize this, we might say chemical weathering works through chemical reactions to change the composition of a rock. So we have our one-sentence summary of chemical weathering in the margins. So if we were to come back through, we could read just this sentence and know what we were talking about. Let's try it again. This time we'll read together. You guys can highlight as I read, and then I'll give you guys a chance to make your own one-sentence summary. No longer stable. Most minerals form at high pressure or high temperatures deep in the crust or sometimes in the mantle. When these rocks are uplifted onto Earth's surface, they are at very low temperatures and pressures. This is a very different environment from the one which they formed, and the minerals are no longer stable. In chemical weathering, minerals that were stable inside the crust must change into minerals that are stable at Earth's surface. If we were to highlight in this passage, we might put high pressure, high temperatures deep in the crust. Earth's surface, low temperatures and low pressure. And then minerals that were stable must change to minerals that are stable at Earth's surface. Let's highlight this whole thing. So we've got a lot of highlighting going on here. High pressures or high temperatures deep in the crust. At Earth's surface, there's low temperatures and low pressures. So minerals that were stable inside the crust must change into minerals that are stable on the Earth's surface. Work with your elbow buddy to develop a one-sentence summary of this no longer stable. Please pause the video. To summarize this, we might put minerals below and at Earth's surface have different stabilities. They must change. So we have minerals below and at Earth's surface have different stabilities, and they must change to become stable. Now you guys have seen a couple examples of how summarizing works. Please try to use the summarizing technique with the rest of these passages in our chemical weathering chapter. When you are finished at the end, there is a flowchart to complete, very similar to the flowchart that we did on Tuesday.